So what you see on screen is the network that is rendered from the data set that we just uploaded. Each circle represents a person, and each line represents a connection that was reported between those persons. Now, what this is a physics simulation. So when I zoom in, you can see that each little circle has the ability to kind of repel other circles on screen and kind of push them away. The whole purpose here is just to lay out the network with the minimum number of crossing lines possible so that we can create a visual that is most informative. And so you can drag nodes around on screen and position them, but ultimately the goal here is to just get everything visualized all in one place. The important thing is because we have layered on, in addition to just the network, all of the other information about the individual, we can connect up other information. And so the simple example is from this pull-out menu in the gear in the top left corner, we get a first menu of how we'd like to color all of the nodes. Or how we'd like to style, color, not just color, a lot of different capabilities here. So first I'm going to map label to ID, and you can immediately see it updates the image with an ID, and you can change or manipulate that label size or the label positioning to best meet your needs. You can also map other things to the hover icon. So when I hover over this, you can see that it will pop up with the ID because it defaults to ID, but we can map that to another visual data point as well. And so we'll map it to age. And now when I hover over each individual, you can see that it pops up with an age. These are kind of the high-level labels. We can also switch to shape and sizes. We calculate the number of neighbors automatically in the network. So what you can do is size by degree. This is a variable that's going to be included in any data set that you upload because we will calculate the degree. Degree, just with as with source and target, is kind of a commonly used term in network science that indicates how many neighbors a person has in the network. So what we can do is size by degree. You can see everything has readjusted. There's not much visual difference, and so what we can do is scale that up and drag this slider bar. And now we see that the individuals that have the most number of neighbors are also most visually apparent on screen. We can also map shapes. For example, if we wanted to map shape to city, I guess they're all in Atlanta in this dummy data set, so we can map them to a risk factor. And it automatically pops up with a key in the top right corner of what that visual styling parameter is relevant to. So we can remap things here. You don't have to pick what it's defaulted to as part of the visual. So you can say instead of plus signs, let's make them diamonds. Instead of diamonds, we can make it a square. And instead of squares here, we'll make it an X. In addition to that, you can actually manipulate the key as well. So if your data just says het, but you actually mean heterosexual, you can actually type that out. Or instead of IDU, you might want to say person who injects drugs. And you can do this so that you can dynamically create the key for the visual that you'd like to produce. So men have sex with men, and it automatically kind of adjusts the size, etc. We can also do the same thing with colors. So here I'm going to color nodes by, I guess we could do zip code. We have a few different zip codes in the data set. And so it automatically pops up with what that zip code is colored as in the top right in the key. But you can remap some of these, so I'll color one of them as black, and you can see that this group over here is primarily in one zip code. And so that is the most of the visuals. There's one other thing that we can color by, which is we can color the links by the type of contact that was reported. And so we can extend this key, oops, that was number of contacts. I meant to go by type. And so here, again, we can choose the particular color that we want. Let's make that a darker blue. And we could make one a darker red to create a visual that really has as much information layered on it as possible. I really wouldn't recommend layering on this much information. It's a bit too much color and a bit too much shape, but it is a good demonstration of what we can achieve in terms of customizing a particular visual. All right, so what I have created here is quite a busy visual with lots of different colors and lots of different layers on top. So we're going to remove some of those just to make it a little bit less busy. So we'll get rid of the shaping, and then we can get rid of, we'll do a color by risk factor to minimize the number of colors. And then that will at least create a little less busy of a visual to work with. And then we'll move on to the links tab, where we have a lot of the same visuals. We've shown coloring by links, which you can click color and it will allow you to color the links by the type. We can get rid of that as well. There are a lot of other visuals here for links, so you can change the transparency. A lot of the times folks want to de-emphasize links because any one link in any particular network may not necessarily be the most confident bit of information, and so many clusters that are rendered as posters or in publications, they tend to de-emphasize links, so you can change that transparency setting. We also enable you to set the width by a particular visual or data characteristic. You can change the length. As you see me drag this slider bar, this cluster here shown on screen gets larger and larger and larger. So in some cases that's useful to really get an idea of how dense or how tight a particular region of the network is. You can see here everyone is connected to everyone. And so you can't quite see that as well when the links are all short. And so that's one thing that you can do. You can see that we've layered on a number for each link, which is the number of contacts between each pair. And so what we can do is get rid of that as well to get a more interpretable visual. If you have information about the direction of naming or the direction of a particular link, for example, person A named person B as a contact and the data that you've entered in is in that format, then you can layer on the arrows as well to show the naming. And that really just depends on the format of the data that you have installed. Or loaded. So if it's person A is connected to person B, it's going to be an arrow from person A to person B. We have another tab that shows visual information about the network. It also enables you to kind of customize the visual on screen. So one thing in this network tab is the ability to highlight neighbors. So if I check this box and then highlight over a particular node, you can see that it shows only the neighbors of that node. So that's one visual that is sometimes informative, especially when the network is very dense with a lot of links and you really kind of need to peer inside of a particular cluster, you can see exactly who is connected to who. We can turn that off and then open up the physics tab. The physics tab really enables you to customize the physics simulation where the nodes or the circles are pushing against each other. So here we have a charge slider bar. This indicates the charge that each individual node applies to everyone else. And so if the charge is low, they're not pushing hard against each other and it all kind of collapses. If the charge is high, they all push extra hard against each other. There's also a gravity feature that kind of keeps everything centered on screen. So we can change that slider bar that has mostly the same effect, but you can see that this has a stronger effect of packing individuals into the center versus packing individuals in and around the cluster that they're most tied to. And so depending on what you would like to achieve on screen, you can play with these slider bars to get there. And then in addition to that, once you've kind of found the visual that you want, so let me take off node labels to find the visual that I want to export. And now that I've done that, we can make slight customizations. And so in this little tray in the top left corner of the network window, there are a few options. One of them looks like a thumbtack that says pin all nodes. If you click that button, now every node is frozen in place and kind of freed from the physics simulation that we just described. This will allow you, so you can see that these two kind of look like they're overlapping, so I could pull that individual out to the side. And you can kind of visually inspect and see if there's any two that are overlapping that you'd like to drag a little bit separately to better emphasize disconnection. Like here's a good example. We might want to drag that off to the side. But ultimately, once you've done that, you can then go up to the top left corner and hit the download button. The download button will take whatever is visually shown on screen and export that according to your specifications. So here I will export a test file. We have a few different options. You can export it as PNG, JPEG. One of the more valuable ones is SVG, or scalable vector graphic. This allows you to take the image and blow it up as large as you would like it to be. So if you've ever been to an academic conference where they have posters, most of those images, the way that they get blown up so large is that they're a scalable vector graphic or extremely high resolution. And so you can export that in any of those file types. We do have the advanced option that will allow you to scale the resolution of that particular image. And then when you export, it will, assuming you have the settings set up properly in the browser, it will prompt you exactly where you'd like to put that file. Now it's important to note that by default, Google Chrome and most other browsers set a download directory. And the files that you download go automatically to that download directory. You can actually specify in the application to say, hey, I'd like you to ask me every single time where you'd like this file to go. And so I've done that here and told it to prompt me exactly where the file needs to go. And that's just good practice for when you're working with very sensitive data. And oftentimes you have very strict rules about where those data can exist. So here I'm going to save it to our desktop because it's a demo file. And we can take a look at what that image looks like. So we've got a little MicrobeTrace logo in the top left corner, and you'll notice in our export menu, we do allow you to scale that watermark so that you don't have to see it as brightly as we have it there currently. You can drag the opacity slider, you can make it larger or smaller, etc. If you do get lost, if you're zoomed way in, You can press this button to reset that zoom and get everything on screen. The same goes if you're zoomed way out and you don't know where you are. You can press that button and it will redirect everything back on screen. And I'm just going to show a lot of the other visual characteristics that we can look, or visual views that we can look at these same data on.